general, you're supposed to count this one. Sir, when you tally, you don't get the total? Tally?
You can, but it's so easy to read them off because you're counting in fives. You don't have to. And since I didn't bother with the percentages.
But you have to for the frequency thing. You have to.
Oh yeah, yeah.
When you do the table, you put the ranges on top with the frequency under. Can we do it the other way?
Oh yeah, that doesn't matter. Yeah, as long as you clearly label it, it's fine. Pen. Sorry, could I just have the pen off you, please? A spare one. Thanks. I'll just take the attendance before we go on. Michelle is sick, isn't she? Yeah. A beer? Yeah. Autumn? Yep. Celine?
Yes.
Where are you? Oh, there you are. Sophia? Mubarak? Where? Oh, there you are. Chadira? She stepped out. Yeah. Mohammed?
Here.
Sabrina? Yeah? Yeah. Moza? Yeah. Angela?
Yeah.
Yeah. Oh, Michelle, how are you? I can give you attendance for the second class? Yeah. Ahmad? Sahra? Lucas is gone, isn't he?
Yep.
Neil? Mahmoud?
First class, yes.
He was here, wasn't he? Yeah, so yes and a no. Okay, Gafar? Amjad? Yes, unfortunately. Zara? Mo? Double unfortunate. Daniel? Savi? Sabrina? No. Alfreda? No. Aria? Yes. She just wanted to do this for me. Chidi?
That's to show that he has good memory. Young friend.
Yeah, but he doesn't remember to be quiet in my class. Young Peng? Yes. Amna? Mariam? Good job, Amjad. It's a pity this isn't on the exam.
A star attendance.
Yeah. Your attendance grade is excellent.
Sorry.
Yeah.
How many weeks do we have this semester?
I haven't a clue. I barely think about what's going on tomorrow. I have too much to be doing.
The semester should be 20 weeks.
I'm afraid
Are
our
the
work
exam done?
has finished it on time.
You must believe me. Sincerely, I think as far ahead as tomorrow. That's all.
So far so good? So far so good?
What's so far so good?
Like the results? I don't know. Or horrible?
There is some concerns.
You're talking about the math final.
Yes.
How many A's?
I know the answer.
Or
But-
A and this
Let me put it this way. I'm not concerned by the high number of A stars. I'm more concerned about the other end of the grade distribution. That's not to say that there aren't A stars. It's just my attention is on the other side right now.
So you forgot about that. So.
No, people got it. Look, just put it this way, Amjad. Who should I be worried about more? People who are doing well or people who are not doing well?
Both.
Not both. Not both.
So the ones who got A stars
I-
will get low grades.
I only care this much. to care about the good and bad students, I would need to care this much.
No.
So, because I only care this much, I can either care about the good ones or the bad ones.
There's a priority.
You know? So, yes. Yes. Yeah. I'll put them with your student number on the notice board. So you need to know your student number. Outside Sylvia's office. Yeah. No, just that's just how I do it. Yeah. It's easier that way. You might have got other grades in individual tutorial. Yeah. Okay, let's continue now. Cold? Cold?
That bad.
Alright. Listen up. Listen. Listen. Right, so the next lesson we're having a look at is averages. And you would have learned about averages already, but we're just going to expand a little bit because we're actually going to have a look at different types of averages. So, you have the type which you all know and first learn about in school, which is actually called the mean average. And this is the one where you add up all your data and divide by the number of data. And this is the one you all learn in school, right? This is the original one. The next one that you learn is the median. That's median average. Does anyone know what this one is? Yeah, it's the data that's in the middle. It's the number that's in the middle of your data. Yeah. The next one is the mode. Yeah, the most frequent data point. And there's a fourth one that you could use, which I just call it the midpoint average. And that one is the smallest value in your data plus the biggest value in your data over 2. There's actually 4 ways to get the average. And they all have advantages and disadvantages. And they're all used in different situations. Okay? So I'll give you an example. Let's have a look at some numbers and let's calculate it. So let's just keep it simple. Let's say we have 5 numbers. So we'll have 2, 1, 6, 1, 5 as an example. Okay, let's get the mean average first. So that would be 2 plus 1 is 3, 3 plus 6 is 9, 15 is it? 15 over 5, which is 3. Let's calculate the median average now. So what we do is we reorder these from min to max. So that's 1, 1, 2, 5, 6.
2.
Who's in the middle? 2. So the middle number here is 2. Right, the mode.
1.
Well, which number? There's only one number that is repeated. So here is 1. And this one, min plus max over 2, what's that? Yeah, 2 plus 5 over 2 is 3.5.
What about the range?
Well, the range isn't a type of average. But yeah, range just means max minus min. Yeah. Yeah, that'll be coming up later. So do you notice actually, we have 4 types of we have 4 answers. If I say to you, what's the average? That's not enough. You need to say, well, which average? So the mean average is 3, the median average is 2, the mode average is 1, and the midpoint average is 3.5. And like I said, each one has a different use in different situations. Yeah?
If you had 2 2s, what would be the mode?
Yeah, exactly. I was just about to say that. What if it's not clear for the mode? So for example, if you had something like 2, 2, 1, 1, 5. What's the mode here? Well, you have a tie, don't you? There's a tie. 1 and 2 are both tied. No. If it's a tie, there's no answer. Okay? The same logic goes if you have something like this. 1, 2, 3, 4, 5. No mode. There isn't a clear number that is more frequent than all the other numbers.
What if it's an even number of numbers?
Yeah, so what do we do if it's an even number? So that was the next thing. So suppose you had something like this. Let's do another example. Let's say we have, so this is another example. Let's say we have 1, 2, 2, 3, 4, 5. So there's 6 numbers here. What's the median? Well, the problem is there isn't a clear number in the middle. Because if you draw here, you could go cancel left, cancel right. Cancel left, cancel right, 6 is in the middle. If you do the same thing here, cancel left, cancel right, cancel left, cancel right, cancel left, cancel right. Oh, you haven't left yourself a number in the middle. And this is because there is an even number here. So what we do in those situations, we take the middle of the middle 2. So in this case here, it will be 2.5, yeah. Does this data have a mode?
Yes.
What is it? 2. What's the midpoint average? 3. And what's the mean? Let's see, 5, 6, 7, 8, 9, 10, 14, 17 over 6, or whatever it is. Yeah. Okay, so that's just to begin with. Now, which average should we use depends on what data that we have. So, can I scroll down? Yeah. So, the first one is fine when your data, it has no outliers. Does anyone know this word, outliers?
Yes.
Yeah, what's it mean?
Values outside the...
Yeah, but not just a little bit outside, a lot outside. Okay? So, what data can you think of that has most values close together, but then there's 1 or 2 values which are just way out there, totally different to the rest?
Weight.
Not weight, no. No, because no matter what, I know most people's weight in this room will be between 0 and 200 kilograms. There's nobody in here which is 1,000 kilograms, right? Just checking. No. So, not that. Not that. Can we think of another data set where most values are kind of clumped together, but there's 1 or 2 numbers which are just way out there?
40 to 80.
Boiling points?
Boiling points? Nah. No. Say again? No, because most blood pressure is within a particular range, you know. Oh, come on. Think of some data where 1 or 2 of the values are just way out of kilter with the rest.
IQ?
Nah, because most people's IQ will be between 0 and 200. There's nobody that's going to be 10 million, you know. No. No. Not even close. Nobody? No. Okay. Income. Money.
Okay.
Yeah. Yeah. Most people's income is within a certain range, but then 1 or 2 people in the data set will have like 100 million. Right? So, you can't use the mean for that data set. And what's the reason for that? It skews it. Yeah. Because think about it like this. If you had data, let's say, 1, 2, 3, 4, 5, 6, 1, 2, 3, 7. What's the mean average here and the median average here? They're both 4. Okay? Now, if I change this 7 to 7,000, the mean changes, doesn't it?
Yeah.
In fact, the mean becomes, 7,000 plus 6 plus over 7. That's going to be much bigger. But for most people, most points, this data hasn't really changed. So saying the average has gone from, say, 4 to 1,000 is a little bit misleading because it makes you think that all your data has grown. But it's only because one value is so extreme. Alright? So anyways, the point is you can only use mean if there's no outliers. Okay, when can you use median? Median is actually pretty good for most situations, but it works really well when there are outliers. So median will be good to use for income, average income. Okay. When is the mode useful? Well, the mode is really good when your data has lots of similar values. So what type of data might that be? Could be something like, yeah, something like that. Age in a classroom would be good. Like in a high school, you know, in one high school, maybe most students in a class are 16. So that would be good when it's compact and similar values, like age. And then when's the for midpoint? When might that be good? Midpoint is usually good when you just want a quick way to estimate. You know, so like if I give you 1,000,000 numbers and I say what's the average, it'll take you a while. But if you want a quick estimate, you can just see a quick look at what's the smallest, what's the biggest, and divide that by 2. Okay. So like I said, different situations mean different ones here. Right, let's have a look at a more complicated one now. So that's if you have data. What about if you have a table? So let's say you have something like this. So let's say this is shoe size. So you could have, let's just say, 5s, 6, 7, 8s, 9. So maybe this is 3 people, 4 people, 6 people, 2 and 1. And this is the frequency. So if you want to calculate the average here, the mean average that is, yeah, well, how many people have a shoe size of 5? 3. So it would be 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6, and so on. So a quicker way to do that would just be 3, yeah? 3 times 5 plus 6 times 4 plus 7 times 6, etc. Over what? The total frequency. 3 people plus 4 people plus 6 people, etc. Okay, so that's fine. How would I get the mode? Well, that's easy here. What's the mode? What's the most common shoe size? A 7. Yeah. A little bit harder now is the median. Yeah. What's the total frequency here? 4, 7, 12, 13, 14, 15, 16. Isn't it? Is it 16? Yeah. If you had 16 people and you arranged them from smallest to largest, which person would be the median in a group of 16? Well, the 8th and the 9th, because it's even. So somewhere between the 8th and the 9th. So where is the 8th person in this group? Well, the 3 smallest people are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So this is the 8th person, this is the 7th person. And what did we say? Where's the median? Between the 8th and 9th. Isn't that what I said? Yeah. So it doesn't really matter because both the 8th and the 9th person has a shoe size of 7 here. Yeah, so it's 7 then.
What if 8 was in one group and 9? Yeah,
I was kind of hoping that wouldn't happen because then it becomes a little bit unclear. In that case, I would take the average, so I'd say like a 6.5. If you need to be between the 7th and the 8th, the 7th and the 8th person, for example, and one is in one group and the other has jumped into the next group, then the median, just like before, is the middle of the 2. So you add and divide by 2. So I would say a 6.5 would be the median then. Okay. Is that okay? Yeah. And then the last one, the midpoint, well, that will just be a 9 plus a 5 over 2. So in that case here is a 7. Now, what you notice is I got the same answer for all of them. And that's actually a feature of data. As the data becomes bigger, you have more of it. As long as it's normal data, then you'll actually discover that the mean, the median, the mode, they'll all tend to be roughly the same number anyways. And that improves as the data set gets bigger. Okay. Right, now the next situation is, what about if you have something like this? So let's say it was something like 1 to, we'll go back to the one we had earlier, 1 to 3, 4 to 6, 7 to 9. We'll say we'll have 6 people, 2 people and 10 people here. And we'll make this, I don't know, number of phones that you own, like this. So 6 people have 1 to 3 phones, 2 people have 4 to 6 phones, and 10 people have 7 to 9 phones. Yeah. Huh? Number of cars possibly too, yes. Number, whatever. Now, we have a problem here because we don't actually know precisely for these 6 people how many phones they have. Some of them have 1, some of them have 2, and some of them have 3. Yeah, so what would be the best number to estimate that they each have? 2. 2 here, 5, and here 8. So by using the mid point in each, you can estimate the average. So the mean average is roughly 6 times 2 plus 5 times 2 plus 8 times 10 over, no, not 3, be careful.
20.
No, 18.
Oh, 18.
That's a 6, sorry, 18. Because remember, this is how many people you have, and this is the sum, the total. What's the median here? Median? Are you sure?
79. The ninth value.
We have 18 people.
Yeah, the ninth.
So the median will be between 9 and 10. The 9 to 10 person are both here. So what's the median? 8. You estimate that the median is roughly 8. And what's the mode? Also roughly 8. By the way, what is this? Is it nearly 8 as well? 18, 90, 102 over 18. Okay. So the reason this is 5.6 is because I think these 6 people are bringing the average down. Much like your grades. Okay, continuing on. Oh, sorry. I shouldn't be saying that. Okay, continuing on now. No, I think that's kind of it. I just want to do one more example. Yeah, I'll just do one more example here. Can I scroll down?
1 second.
Okay. All right. Okay, so the last one here. Let's say somebody gave you this data. Maybe, I don't know, it's income. We'll say that there's 4 groups. So there are people who earn per year, let's just say, less than 10,000. So I'll just write 10K for 10,000, okay? And then this one here, their income will be between, I'll write 10,000. No, I'll write 10K. You all understand K means 1,000 for money, don't you? Okay. 10K. For this one here, we'll say it's 10k to, let's say, 20k. This one here is 20k to, let's say, 40k. It doesn't have to be the same. And this one here is more than or equal to 40,000. And let's say this is 5, 6, 10, 2. Now, we want to calculate the average here. So we have to use middle point estimates here. So what's the best estimate for this group of people for their income? 5,000, we'll say. Because since we,
zero.
yeah. You can't really earn less than zero. You know, that'd be like me coming here to teach you and paying the school for me to do this. You would have to be crazy. Yeah.
Yeah, if you're in debt, then you own.
Yeah, but we're just talking about income, like salary, not your net worth, your salary, how much you're being paid. You're not going to pay someone to work for them. Right. Okay, between 10 and 20, 15,000. Between 20 and 40,
20.
30,000. Now, here is the interesting one. What are we to do about the last group of people? All we know about them is that they earn 40,000. No, sorry, that they earn more than 40,000.
655. No.
60,000.
Yeah, but yeah, that's the point. Like, how do you know, and what
Is it
number
the
should you
pattern?
pick? Kind of a pattern, yeah.
It's doubling every time.
Oh no, that wouldn't quite be it.
No.
No. So look. Anyone have an idea of how to estimate the last group? So
30 plus 15 plus 5 divided.
close. Let's look at this. This group here, we say most people will be 5,000. Although some people could be 0 and some people could be 10. So there's a plus or minus here of 5,000. Now here, we're saying 15, but what's it here? Plus or minus of 5,000. So the person earns 15, but they could be off by plus or minus 5,000. This one here,
10.
plus or minus 10,000. Right, what's the average of those three errors? 5,000, 5,000 and 10,000 is 20,000. 20,000 divided by 3 is it? 20,000 divided by 3, I don't think is that. 6,000, is it?
5.
No.
What?
7,000.
6.6.
6,667.
Yeah.
20 divided by 3, isn't it?
If you round up, yeah.
Yeah, if you round up to the nearest euro.
Yeah.
Okay? Yeah. So look. Whatever we pick for this box for its middle value, there's an error. And the error should have you at the low end finish in this box. So we know that that must be 40,000. So I think a good estimate here to use is 46,667, because if you go 6,000 roughly to the left, you'll end up at the start of this box. And 6,000 is my best guess for how big each box is, because this box was a plus or minus 5, this was a plus or minus 5, this is a plus or minus 10. So my best guess is that these people earn 46,667 plus or minus 6,667. So that's like 40,000 to 53,000.
Sir.
Now, it could be that one of them earns 100,000. You're just making your best guess at what you think that last group looks like. Yeah?
Why not use 45,000? Because it's plus or minus 5, plus or minus 5, plus or minus 10. Then it's plus or minus 10. Should be a pattern like that, right?
No, it shouldn't be a pattern, because it depends entirely on whoever calculated and collected the data together. It's not like the person sat down and said, you know what, I'll make a nice arithmetic pattern here so each box gets twice as big. You know, like they could have many reasons for making this box bigger. You know, maybe they decided to make this box bigger because there's most people in this range, you know. And maybe they decided to make this box smaller because not many people would fall into it anyways. You know, like, you don't know what the rationale was for the choices that they made. But the best guess I could make for the last one is 46,000. Yeah. So you know what to do next for the average. It would be 5,000 times 5 plus 15,000 times 6 plus 30,000 times 10 plus 46,000 times 2 all over 23. Is it? Or whatever it is. Yeah. See, this is quite a common thing in the exam. It's quite common that they would give you a table like this and ask you for the average. And you really have to think about what numbers you use. So you'll have to think about, could I be negative, for example? In this case, no. Anyways, it'll be a little bit better when we actually look at exam questions, but we really just need to get the ideas in our head right now. Oh yeah, and the last one, suppose there was a box here. I'll just add it in here, well, whatever. There's another box here of people who answered the question, don't know. So it does happen in surveys. You ask people how much they earn, and let's say 2 people said, do you know what? I actually don't know. How do we treat that? Yeah, there's actually a couple of choices. So one possibility which is allowed is you just delete that from your data. What else could we have done?
Randomly added to
Put it in the
any
median?
of them.
Put them in the mold.
Me.
Oh, interesting. Randomly put the 2 of them in one of the 4
Yeah,
boxes. Acceptable. Yes. Anything else?
Put it in the median.
And then
Add them to the
Middle.
middle.
Yeah.
Yep. Acceptable.
Add them equally into each one.
No.
So in this case, we
Oh, so
0.5
add half a person to each box.
Yeah.
Acceptable. Unusual, but acceptable. So anyways, the point I want to make with this is that when you're collecting data for when you're doing medical trials, you know, you probably know your income. But if you were giving people medication and you asked them, for example, how they were feeling, or perhaps they dropped out of the study, you know, you were giving people 10 weeks of treatment and in week 9, 2 people dropped out. So you don't actually know their answers to how they're feeling. You actually have many choices on how you deal with those 2 people, but you must deal with them. You can't just ignore it. So whatever method you choose, you have to mention that in your article. So if you say the 2 people who dropped out, I deleted them from my data set, that's fine. If you said I gave them the value of the average of the group, that's fine. Now here's the thing though, will you get the same answer for each of those choices?
No.
No. No.
This will always skew.
Yeah, it'll always be slightly different. So if, for example, he decides to add the 2 people among the 4 boxes, if you decide to, what did you say to do? Randomly put 1 in one box and 1 in the other, they'll get slightly different averages. Now just think about this for a medical trial and give me your answer for
Does
this.
that have the same average if I add?
For a medical trial, you think of other variables, like are they male, are they female? Stuff like
Yeah,
that.
no, but let's just say we're asking people you were giving them some drug. Normally for medical trials, you want to know what the side effects are. So you give them some drug and you say, did you have headaches? Whatever, okay, like this. So let's say after week 9 of 10, so it was nearly to the end, or well, more realistically, they drop out in the middle, week 5 of 10. 2 people dropped out. You could give those 2 people who dropped out the value of the other group. Do you think that would have an effect on your conclusion? It would. Do you think it would make your conclusion look better or worse? Now just think for a moment. 2 people have dropped out and you decide the best thing to do is to give them the value of the average of the other people who stayed in the group. Do you think that will affect your result, and would it be a good or a positive effect?
To affect.
Yes,
Good.
it'll be
Depends
bad.
on what the average is. If it's a good
It'll be bad.
average.
It will be better.
No, I don't think it would necessarily depend on that, actually.
As in, if it was the average was what they wanted it to be.
I don't think it would depend on that. No.
If it was what they wanted to be, wouldn't it be like a more
If it was what they wanted to be, but it doesn't even have to be that. It can be something else. Were you saying something, Amjad?
It will affect, but in a positive way.
Why in a positive way?
Because if you ignored them,
Reducing your sample size.
Well, that's true too. Okay, so for medical trials, when people who drop out, usually they give the people who dropped out the average of the rest of the group. This makes your result look better, because a common reason for people to drop out is they're very unhappy with the side effects they're getting. So if you could ask them, were the side effects good or bad? I'm talking up here.
Yeah.
If you could ask the people that dropped out, were the side effects good or bad, they're likely to say bad, because they dropped out. If you include that data, do you bring the average for the side effects up or down? Do you make it better or worse?
Down.
You would make it worse. If you could include the dropouts. So do you realise that if you replace the dropouts with the average of the group, you're making your data look better?
Yeah.
Because you have people who dropped out because they were tired of having headaches every day. And you said, oh, I'll replace them with the average of the rest of the group. And they didn't drop out because the side effects weren't as bad for them.
But that's wrong.
I know, and this will tie into the active lecture. You know, this is the point I'm making, that you can manipulate your statistics to make your result look better. But we can all understand that this is a bad thing to do. Yeah. The best thing to do is probably just to delete those two people from the data set.
Yeah.
But even that is making your results look better, because if you truly had their value, then it would bring the average down. This isn't simple stuff to figure out what's the best thing to do.
The best thing is always to remove.
No.
Yeah.
include it, because like,
No. Another
Because
thing.
then you're being true to the values that you get.
Yeah, but you've deleted some data
It'll be
because
less accurate.
you knew how they were doing before they dropped out. You know. Yeah. So you see, it's not clear cut. Anyways, we'll wrap it up there. You can try these averages at home. They're not very difficult, and you can be thinking about your statistical dilemmas.
Going back to one point, let's say